All right, everybody, we are going live with live coding agents. Today, we're going to do a speed run, so it means focused. We're going to jump right into it. We're going to go to our DSPy fundamental project. We were working on Google Cloud stuff yesterday. Didn't really pan out, unfortunately, but it's fine because we got plenty of other stuff to work on. So we're going to go, we're going to attach DSPy gen to DSPy fundamentals so that we can leverage some code that we already wrote. There's plenty of that code. So let's attach it. Okay. So we've already got agents, a lot of agents, CoderAgents. But let's go for the commands to execute these. So we go to our subcommands folder here, agent command. Okay, so this is from the agent system you're doing. So this is the actor system. This is a little bit different than the agents. I just want to focus on agents for the fundamentals project, not on the actor system, which is more about like coordination and things like that. We're gonna bring it in. I don't know how to make the YouTube box smaller, but that's just life. So we'll work on it. We'll work with what we got. All right. So we're going to cancel this. We're going to go to our fundamentals project, and we're going to do. We created last time an alias for the DSPy fun. So we have the Google Cloud. We're going to ignore these, but we do have this subcommand. So we are going to sub cmd new, and we're going to call it agent. We're going to have code. Okay. So this should give us a always add. This should give us an agent, a code agent function. So we have our code agent. So let's create an agents folder here, or a package. And we're just going to move our CoderAgent over first, version 4. Paste. Okay, so it has all this DSPy functionality. So we're just going to run it, and this is running Olama. And let's get it started. So you can see that it has all these different states that it goes through, but you notice that it's not triggering the states itself. It's using the language model to trigger the states. But we're going to use it since we know what we want. We're just going to have it go through the states itself. So we're just going to delete this code. And so what we can say is start coding. You write the code to the file. And then once you've written it to the file, we want self.test code. Strange. Oh, we return it. So, that's okay. So that's incorrect.
Yeah.
What's up, Batman? I can tell already by the meow. So we crashed and burned with Google Cloud. The authentication didn't work at all. So we're moving to coding agents right now. And so we're just making them as efficient as possible. This follows the frozen swarm pattern, which is basically, these are agents that could be self-controlled by language models, but we're just going to actually we execute the code here. We're just going to change the states themselves. So self.handle errors, refactor. So we go from testing code, refactor to handling. So self.handling errors. Then we complete, and we go to completing task, self.complete task. All right, so let's agent dot, what is the first, start coding, and make a request to an API and return the response. Right, so let's see what we don't have it generate the file to a certain place. So we take, this is a DSPyGen module. So we're writing Python code. So one of the things that we'll want to do is maybe make it so that this can write any kind of code, which I think would be cool. It's a feature we can add. And we'll just take it from here. Let's see what happens when we run it. Oh, actually, not where we're not going to run it ourselves. We're going to run it from our CLI. So we see coder. Actually, what we can do, and this is the whole the reason why there's the pattern, is we have this main function. So we'll run the main function. No module inject. Okay. That means that we need to add PA inject. That's for the dependency injection. We unfortunately broke Dr. Vogel's code. He's working on something really cool. I'm excited to see it. But right now he's got it secretly locked in the lab, which is fine. Okay. Oh, I haven't pushed an update to the, all right. Sorry guys. It's because we have this in here. We don't want to just add stuff randomly. So when you detach it, it should stop doing that. Yeah. So we're analyzing the requirements. Okay, perfect. Okay, so code written, requests, right? A snippet, function declaration, right? Test failed. Okay, cool. Unterminated string. So what we need is a function that extracts the code based on triple backticks, right? So we have our utils folder, and now we can write. So this is where we come into what are we going to name this? Because it could go a couple different ways. It could be like Markdown because we're trying to get the triple backticks of Markdown. It could be a language model because we're trying to get this code from a language model. It could be code tools and I think as I'm saying this, Markdown makes the most sense. So we're going to create a Markdown tools. Okay, Markdown tools, and we're going to go get we're going to use Cursor for this because Cursor is better at generating code. So we're going to just close all these. Close all. Close all. All right, we have our Markdown tools. So we're going to say, create a function that will extract any text within triple backticks of a Markdown string. Okay, cool. So the problem is that this will, I know for a fact, still grab the title. So won't Well, we can come up with a unit test for it. That's actually better, even better, because I have my feelings or thought about it, but I don't have a test to validate that. So what we can do is we can go to our test folder, and we have a new folder. I guess we should do a module. So for this, we'll go back to here. New package. We'll call it utils. PF test. All right. So then we have our utils, test markdown tools. And we can say, create unit tests to validate the markdown code extraction function. And what we can do is we can target mark. There we go. No. Okay, so no, no, I want PyTest and test like Python. Make sure that okay. So we'll accept that. We'll say this is wrong. Python should not be included. Okay, accept. Right. So this should fail for sure. It should be this, right? We want it to be this and this. Because that's the whole point, is we want properly formatted code. Actually, a new line at the end is not a problem because you want to have a new line at the end in Python anyway. So actually, that's not a problem. We'll keep that. So we have this. And so now let's go run it in here. And actually, we don't need this because of the way that the tests get run. All right, cool. So what we do is we will reformat the file. And then I need to talk to the AI. So in reality, we're going to do this. And we're going to do this. Can you change the to pass all tests? Okay. 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 So this is going to probably be all over the place. Yeah. Because it's the way that it's like the dedent, meaning that like the indentation is broken. So first off, let's try this. I want to see if this works first. Yeah, it doesn't work at all. This is actually like a very big challenge. I have code from an older project that I'm going to look up to see how I handled this. So it's funny is I think if GPT-5 is able to figure out this, then would finally be able to say AI is smart. But also by the time that we get GPT-5, so many people have been trying to figure this out that it might work. Okay, so we have, let's open, oops, cancel. Let's open dev. Sorry, guys, I have to go back in time. So actually, I'm going to just do a Google search. Or actually, I think I have Gemini. We'll check Gemini out. It's been a while since I've checked out Gemini. Maybe it's improved since last time. Can say, can you create a Python function to extract the code from Markdown triple backticks? Okay. So let's try this and see what it comes up with. So I don't know what the hell this language code is. And it got weird. Let's run the test. See what comes out. Okay, again, nothing. Okay, so see. That doesn't work, period. Let's think step by step about 5 different approaches to solving this and then try to choose the best one. Oh, state machine. Oh, okay. So let's look up mistune. Mistune. Okay, so let's say, how would we extract the code blocks from a string in mistune? Okay. Dot code blocks. Okay, so let's try mistune because I'd much rather, considering how tricky this is, I think a full-on parser would be better. So let's PA mistune, and we can extract. replace. Reformat the file. Let's run the file. Okay, so okay, so let's see what we get. Well, one, let's comment this out. So we'll start with this one. Expected output, markdown string. So let's say extracted equals, and we'll say okay, so this didn't do anything at all. Great. I mean, that's definitely a choice. So let's just do this. Self.codeblocks. Okay, so it looks like with code blocks, it's just one. So that, I guess it doesn't register that as a code block. So one, that's improper now that we think about it. Because if it was a code block, we'd say, code. So we'd say like Python. So first off, it was not proper at all. So then code blocks. Okay, so it's not doing anything. Well, let's try a different one. More like a more basic one. Okay. So pick one that looks legitimate. Debug. Code. Okay, so this one, wait, I want to go back one step. Defu. The one that I ran, this one. We'll just put it that way. We know that for sure we're running the right one. Okay, so it doesn't do anything. All right, so mistune doesn't work at all. Parse fence code. Perfect. There we go. Perfect. So use okay, we'll see if this works. Okay, and then we'll just come up with a main. Oh, it's not in this project. All right, def main. There we go. There we go. All right. Okay. Where the hell is R split? All right. Great. Let's go. So this is class block parser. Let's see if Gemini can figure it out. I want to use show. So it's funny, is because we're using triple backticks in the. All right, it's because we're using triple backticks in the code. It's breaking the UI. I mean, it's breaking the UI of the AI. Okay. 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 This is too much. Okay, let's see how this works. This is how they would recommend it in the Pragmatic Programmer. Okay, so it's the fact that it's not dedented. So let's try this, dedent. Okay, great. All right, that worked. That was what I was looking for. Okay. And so we can run it from right here. Okay. So instead of it being a video of me making like code gen and stuff, I mean, I guess this is a video of you seeing me get frustrated by stuff that you guys probably have to go through as well. But that's the thing about this is I'd rather show all of this process versus show like just, oh yeah, it's so easy to do all this stuff every single time. It's just you do one frame video and then the next video. Okay, so this is fine. This is the code block. This works. Okay, so then let's try this one. And again, it's the dedent that we need. Because yeah, I guess like showing this to you guys, because I haven't seen anybody else that shows stuff like this or shows, you know, what it's like to like go through this process. So you're getting it here. Expected output. All right, cool. Here, that worked as well. I mean, whether or not it is happy with the assert, it was I was happy enough with what the result was. Oh yeah, I didn't put the dedent. But I don't know. I mean, if you guys, there's some people watching. If you like this kind of content, just hit the thumbs up real quick so that I know, because otherwise I have no idea if anybody wants to see this kind of stuff. Okay, so that looks right. Okay, so our functions looking, as long as we dedent the code, it looks good enough. So now we have our markdown tools. So what is our function called? It's a long function name. So so we'll just call it that. And so now we'll see what happens when we run this function in our, because we got our Python. So this is our DSPy gen module. So now if we run it, the write code to file, So we have our code. So we can just wrap it like this. And we'll see if this works or not. Cool. Thanks for the thumbs up, whoever did that. Oh, okay. Good to know. Appreciate that. Cool. All right. Well, we're going to get rid of all this fun stuff because you don't want to just leave that around. Stop. Okay, so CoderAgent is doing its thing. Type. Oh, okay. So what happened is our coding, this coding triple backticks returns an array, a list. Sorry, but if we look at it, this is code. This is what we wanted. So it works. So it's just a matter of we want this instead of returning a list. We just want in order to do that, what you do is you do /n/n dot join this. Okay. So what we'll do is we'll print code each time, right? Print. Okay, so you see how we got our code. So then we also wanted to add code to execute it. So now we can look to see what else got added. Okay, so our function call invoke function call did not return anything. Okay. So if we 5. Okay, so it didn't give us any. So the invoke function call was supposed to give us this, supposed to give us a value. So let's look at the forward function of that. So you'll notice that this is from the DSPy project, but I can still debug into it, which is a cool feature of Python. Okay, so let's see what the output is. Make API requests. Okay, so it didn't give us what we needed. So what we're going to do then is we're going to create a, so this is because it's super, super simple, right? Like what we need is, I'm going to just take the module. We're going to skip the pipe. We're just going to take the module like this. And we're going to go to create, we have modules in here. And so we're going to just do one called create def. We'll just call it def invoke. Just keep it simple. And we'll just return function to def. We'll import DSPy. We'll get rid of the or pipe stuff. Okay, so now we have our def invoke module, and then I'm going to go to my signature GPT, and I'm going to say, create a signature for me to be able to create Python function invocations based on the function declaration provided. Cool. So you see how it knows how to use that stuff, which is cool. So let's try it. We're going to just try it without and see if it figured it out, right? So then what we can do is we go back to here, console. We can grab the text and we can create a main def main. And so we don't have to dedent. We'll just call it code here, and we'll just do this. And what you can do, so you see how it already had, you can just do single quotes. So there now it's properly, it'll be properly formatted. And so we can say, we'll create a call. So we call def call, def invoke call. There we go. So we'll say call or invoke equals invoke code, print invoke, if main. And of course, we're going to not forget to add Olama. Fun in Olama. And we're going to run it. Perfect. So that is exactly what we wanted, right? That invokes the function. So it worked. That's all we needed, right? Make a request to a URL. Literally all we needed. And what I'm going to do, I'm going to start doing, because there's not going to be a case in which I want this. I'm just going to now add in here, and this is one of those kind of convenience things where I will, because we're going to be using this call, here I can put this, what do we call it? Extract triple backticks. In here, def invoke, we'll also rename it def invoke module refactor. Okay. So now we'll try it again. Cool. There we go. So that's what we needed. So now we can take this function, go back to our coder agent, and replace function invoke with def invoke. Delete that. All right. So now we stop. We run. Okay. So let's see what happens. Code plus equals. Code plus. Okay, we're not running that, so it skips by it. Okay, so the code that came back, now the code that we have. Okay, so for some reason it's not adding the invocation. So we'll just do this. So now all of a sudden when we're adding the exact same stuff, it's not working. Why? Oh, because we're triple back ticking again. That's why. That's why. And actually, let's do another step that we can add here to prevent that issue, or not to prevent it, but to catch it. Basically, that if def invoke call returns nothing, so self.code plus equals. So basically, in the case where this returns nothing, let's throw a value error. So we'll say code, or we already called it code up here, but we'll call it example. Change this to example. Why is that a problem? Okay, whatever, we're not running it. So anyway, we have code, and what we can say is if not code, raise else return code. There we go. So now we'll save ourselves from that problem because we'll catch it. Like if this for some reason doesn't return code, then we're in business. Now it wasn't, because if you run this on code that doesn't have triple backticks, it'll fail, but we're just working through it bit by bit. Batman's back. It's that cat sound, which I'm not sure how much you paid extra, or I don't know if the cat sound was free. Okay, we're still not get. All right, so then let's call this invoke and so then we'll say there we go. Okay, so now when we do self.code and check it, oh, it's getting posted to the front. All right, well, that's easily solvable. Oh, and actually we can do even one better. Let's make it, well, we can wrap it in a main function. So, so how we can do that is, let's go to, well, let's just run it, handling coding errors. All right, so now we're going to test the code. So let's check out what our execute code looks like. We're running the file, capture output, text equal true, timeout. Okay, so coding passed, handling coding errors. So let's see what the sub process is returning. Okay, so that works. We know that works. Okay, result. Dot standard out. Perfect. Return code 0. So it worked. So then handle errors if they're detected. Execute code. If errors, append error. Okay. So then we need to otherwise complete task. So basically, when we return out back from that, if errors, test passed, output. Okay, so then what we need to do is self.handle errors, else self.complete task, right? And then if complete task, we want to, let's give it to where the coder agent has a, right now we'll just call it file name, API request.py, right? And then we'll say, we'll go to the definition, and we'll say file name is none. Oh, we already had a file name, so okay, file name. And then on the end, we will write task completed without errors. Then it's self.filename is used as the template, the temp file name. So that's what is that file name right now. Let's say output file, since file name is already being used. None. And we'll make sure that it has, and we'll just make it output.py. There we go. That way we don't even have to worry about it. So then it's it's open self.output, and we need to save it up here. Cool. All right. So now stop this, and we can run it. Cool. And let's look at it. Return none, make API requests. Okay, so we need to add 2 new lines. That's what it is. And actually, let's do it even nicer. So what we can do is we can create a, and this is just for, we're going to do this with cursor. So what we're going to say is in our agent, where is it? Agents, CoderAgent. We're going to say, create a Jinja template. Oh, that's not how we do it. Create a Ginger template that takes the Python source code as the first value, and then creates a main function for the invocation to go into. Yeah, perfect. And then we accept. Cool. All right. So we got our template string, code, generate code with main. So that's, and so now we'll go back to here. Now that we have this, we can do we'll just say code. We'll just say PyCode. And we will say generate code with main, PyCode, and invoke. Nice and clean. All right. Now we can run it. Code written. Okay. That, oh, it didn't, Okay, so it uses here, this is the problem. So handling coding errors. Yeah, which is great because that means that it failed. So it doesn't work, which is great. Because we can do PyCode and this should work. Code written? No. Okay. Okay, why is it not working? Okay, so PyCode's there. Self.code. Perfect. Yeah, that looks like it works. Okay, that looks like it works. When we look at the standard out, standard error. Let's look at the standard error. That's great though. That is totally fine. So we had because we're trying to see if this sub process failed. So this is fine for right now because it's the code. So the thing is that if the code is bad, it fails. We're not trying to see if code works. We're just trying to see if the code is correct. Meaning this is fine for right now, right? So let's run it. We're clear. Now we have our API request. Okay, that's for some reason. Okay, so let's. Okay, so I want to see what works. Self.handle errors. Clear. Oh, if error. Yeah. Oh, because it wasn't running it before. So actually, it is catching the errors. Sorry. So let's okay. So it is catching it. It's giving it a bad URL. Let's just, even if it fails, we'll leave the handle errors for later. We still want it to complete the task. So actually, no, we don't want it to. We'll do the on errors. Okay, so right now we don't have the refactor phase. So now we need to go to refactor because we're in the testing code. Yeah, we go from writing to testing. So testing, this is you can, in testing, you can go from here. So then let's try the refactor code function. If error, self.refactor. Okay, cool. So now we will see if it goes into the refactoring phase. And keep in mind, this is all running off of the Phi model, which is the 3.8 billion model, not the GPT-4. So that's the thing, is like, I haven't seen anybody that's able to do this kind of, like, I don't know. I've never seen anybody do it this way. Okay, cool. So we got code. So we got code. Okay, so code added by refactoring. So what I think we need to do is we will put a to do here because we got to wrap up, and let's leave refactoring to a separate pass because there's some different ways I want to handle there set different ways we can handle code generation and things like that. I just want to kind of move on. Um, so we'll just say for right now we'll say to do implement code refactoring. Yeah. And we'll just put right here, complete the task. Because what's more important is to me is that it's writing the working code. So I want it to save it. And then I got to go in the next. Oh, you can't complete the task from handling errors. Okay. So what then we'll do is we'll just add this. Instead, we won't do that. We'll just write the code even if there's an error, and we'll just call it a video, and I'll be back later today. Okay. This is interesting. Can't contribute complete state from handling errors. Is it running the code from somewhere? Oops. Okay, what we're going to do actually then is we're just, yeah, okay. That's the problem. This is on if error. So it's this. We didn't change it. Okay. There we go. Okay. So if we look at it, so what we can do is let's change this to a test endpoint. So let's say test endpoint. So this is actually pretty cool. I've never tried this before. So and actually we can let's try this. Okay. So we can, and then we'll just do print this. Okay, cool. So watch this. This will be the true test. Let's see if we can say in the invocation, invoke code, and then we can say like we'll add here notes. We'll call it additional. Yeah, see, perfect. Additional instructions. And so then we need to add here. Sorry, I'm going to just do this manually. Oops. that equals that. That. Okay. And then that. Okay. Cool. Forward. Well, instructions. All right. So what we can do is let's see if we can add to the additional instructions this endpoint. And let's hopefully it'll use it. Invoke call, we got this. And so here we want to add this and this, and then we don't need to add this because we're already handling it. And then our use to test. Or actually, we'll just say use the URL, right? It should be able to figure it out. So now let's run it. Okay, wait, so function-based. Okay, so it didn't, the indentation didn't hold. It didn't indent each line. So let's, so what that means is that actually in here, what you need to do is we actually need to add indent, or actually what we'll do is we'll do this, because that will make it so that we then indent it ourselves. So we have to do indent. I don't remember how indent works. I think text, prefix, predicate. Correct. So we'll just do 1, 2, 3, 4. And let's see if that works. Wait, let's delete that one more time. And then I gotta go. Okay. Oh, what's funny actually is because it worked, it didn't write it to disk. So there's a bug somewhere where if it works, yeah, oh, because I removed the, all right, I was confused, so complete task. So that it worked it's the error stopped happening. Completed without error. Now let's reload from disk. Let's run the file. Victory lap. Well, let's add one more step, and we'll say the function to invoke. We gave it the function to invoke. We also want to, now that we got this works, and we can say and print the result. Let's see if that works. Because this is a big step, and I'll explain like why this is like a really big step. Okay. So let's go over what I just was able to accomplish with your guys' help. Even if you don't think you're helping me, you're helping me. What can we do now? We have an agent that can not only write code, it can execute the code, it can detect the errors, and we'll add the refactoring step later. But we may never need, if we can always write code that works, then we don't need it. And so I was able to give it notes on how to test. So these notes could also come from another DSPy. So this is where we're getting the reason why DSPy is so awesome, right? Is I could have, and I do have a module that creates file names. So we can create the file name from the code. We can create additional instructions from the DSPy modules, right? We can start adding in. This is exactly, guys just saw the whole reason why I'm doing all this stuff is now I can start adding in very quickly language model tasks for each piece, right? Like I'd like to see anybody else. So let's go to Olama. So we'll do iTerm, and I'll show you guys what I mean. Term. So let's go to Olama. Olama find struct, right? And I will say create a function that returns a response from an API https://http bin.org/get. Cool. All right, so let's grab this code and we'll just give it a shot real quick. We'll say, okay. So I just copied and pasted what was in there and it doesn't work, right? So we'll just patch it up a little bit. So it was one line was off. But the thing is that one line being off already broke the whole thing, right? So if we look at what this did, let's just make sure that it's not because we have the word wrap on iTerm. So it looked like it was, no, you see? So the code that it returned was wrong, had a mistake in it. So this code completely failed if we consider it a complete fail. Now, let's just assume that I'm a human and I see that what's wrong and I fix it. And let's see if it works. Cool. So it works, but the code that it gave us is incorrect. We might have needed another step to fix it, but using my DSPy code, just this Python source code call, who knows what's in there? That's another factor about why DSPy is so cool. Who knows what's in there, right? I wrote it. It could be magic. It could be the most brilliant code generation thing ever. You don't need to know. You just call that, and if it works, you're good. Function invocation, right? We don't have to have the invocation in here. We can invoke it in a separate step, right? So that's the thing, is that I can take a piece of code and then later, let's think about it this way. This is another piece of it, right? Let's say I'm now somewhere else writing. I know I have the function, so we can take this function from anywhere. Then somewhere else say invoke it. So we can invoke it 500 times in another piece of code, telling it each time use a different endpoint, right? So this is the foundation. So another victory lap, and I'll be back later today. So thanks for watching, and I will check you guys next time.